Hello and welcome to today's Learn at Lunchtime program from the State Museum of Pennsylvania. I am Beth Erickson. Our topic today is Pennsylvania's caves, time capsules of the past. And with us is Rosanna Behr, the Karst and Sinkhole specialist for the Department of Conservation and Natural Resources, Pennsylvania Geological Survey. Rosanna has worked for DCNR for 19 years as an environmental educator and geologist. Much of her daily work includes karst geohazard mapping and fielding homeowner sinkhole calls. She is a hobby caver and enjoys doing science in caves in her spare time. Welcome, Rosanna, and thank you for presenting today's program.
Well, thank you for inviting me.
Of course, but before we go any further, we need some clarification. The most frequent question we have received about this topic is, what is a karst? Would you define that term, please?
Karst is a term for the landscape that lies over dissolvable rocks, like limestone, marble, or gypsum. And it's a landscape marked by caves, sinkholes, often dry river valleys or disappearing streams, and then large volume springs. So some of the examples, if you think of Mammoth Cave National Park, not just the cave, but that whole landscape. Or Ireland's County Clare is a famous example. Mexico's Yucatan Peninsula with the cenotes, also a karst landscape. Here in Pennsylvania, the Great Valley, the Cumberland Valley, the Lehigh Valley, Nittany Valley, among others.
So this work must keep you busy. Tell us about what you do at the Pennsylvania Geological Survey.
So like you mentioned, part of my job is taking those homeowner phone calls when they have a surprise hole in the yard or near the house, or they see one in the street, can help them figure out what it is and how to take care of it. I also map the geologic hazards, basically the sinkhole hazards, through some remote sensing techniques, and then also field methods. I do field mapping in the areas of karst in the state.
Well, let's get started with today's presentation to find out more. Rosanna, when you are ready, please begin.
All right, well, let's dig into the cave time capsules. Well, first of all, we have to start by creating the cavity. Well, how do caves form? And we have two different methods. The one is the tectonic caves. And these are just physically opening due to frost action or gravity. We often find these at the lip of a steep slope. It's opened along a fracture and gravity is just pulling it open. Wind Cave in Lancaster County is a good example of that. Now our dissolutional caves, the rocks actually dissolve. So Crystal Cave in Berks County is an example of that. And the way we can dissolve a rock is we start with just rainwater mixing with carbon dioxide in the atmosphere or in the soil, and it creates a weak acid. And that acid percolates down and interacts with certain types of bedrock and dissolves it into sort of liquid components that wash away. Now, when we're talking about this, we're talking about like a centimeter in 1,000 years. So it's a very slow process. But once it gets started, it can get complicated by rivers washing in and physically removing stuff, or roof collapses making it bigger. And these voids formed long ago, but they do continue to grow today. Well, where in Pennsylvania are our caves? Of course, the tectonic caves can be anywhere, as long as we've got some topography to work with. Our dissolutional caves are in the limestone, dolostone, and marble belts of Pennsylvania. So I have shown on the map, the pink are the commercial caves that you can go and visit. The red dots are some of the caves. Often the location is kept private to protect the cave and the landowner's privacy. So Southeast Pennsylvania and Central Pennsylvania, we have some very thick beds of limestone, thousands of feet thick, folded and faulted and altered, and that gives that rainwater pathways to attack. Southwest PA, we have thinner limestones, some of them on the order of only 10 feet thick. They're flat-lying, but the caves can still develop in that. Laurel Caverns, which is in a dipping bed, is our deepest cave, and our two longest caves are in Western PA. So once we have created the time capsule, itself, we can start filling it. And the cave will record a record, sometimes really spotty and sometimes otherwise. And it's anything that drips into the cave or washes in, anything that falls in or crawls in, wafts or drifts, or otherwise finds itself trapped there. On the lower right, we have Delaney Cave, which is not one of our bone caves, but when you look at this entrance, you can picture, that a large animal could fall in there and not be able to climb back out. Or if any trees fell in there, they might just end up in the geologic record. Now, Durham Cave, on the top left, is a wash-in kind of cave. And if we look at the map of the cave, we see the entrance is on the side of a cliff. It's above a river, but then the bone passage is where all sorts of creatures have washed in and their bones have become fossilized and become part of the geologic record. Bootlegger Sink in York County is a fall-in kind of cave. The entrance is this oval right here, and it is just a hole in the forest floor. So anything that falls in there drops about 30 feet and ends up on the debris mound. We have a cross section from C to D shown here, and you could picture how anything that fell in that entrance would have a hard time ever getting back out. So our time capsules contain several different little pieces of the story, little notes from the past. It includes the fossils, the sediments, and the cave formations like stalactites and stalagmites, each telling a little part of the story. So I want to refresh your memory if you have forgotten this over the years, but we have many different ways to date things in the cave. The one is carbon-14, which of course we need carbon, we need organic matter to test. And it's good for dating things up to 60,000 years ago. Optically stimulated luminescence requires some quartz. That could be quartz sand, it could be a quartz crystal. If it's exposed to the sunlight for just 2 minutes, the clock is reset. But once it's buried, it starts to accumulate these impurities. And so we take it to the lab and stimulate it with light. It'll glow, it'll release those impurities, and with that, we can get a date. Now, this could be accurate just 100 years ago, all the way up to 200,000 to 500,000. So the archaeologist, in addition to the geologist, really like this dating technique. Uranium-thorium dating, which is something we can do on the stalactites, can date up to 500,000 years ago. Now, cosmogenic dating also requires some quartz clasts. And when something is out at the surface, it's being bombarded by cosmic rays. And once it's buried, clock starts ticking. And we can date those to 1,000 years ago to 10 million years ago. And we also have just relative dating, sort of the context. If an animal went extinct 10,000 years ago and we find its skeleton in the cave, the chances are the cave has to be at least 10,000 years old. So the fossil record in the cave includes little grains of pollen. Those of you that have allergies and the seasons make you sneeze, well, that pollen is wafting into the cave and getting stuck and becoming part of the record. There's seeds and nuts and leaves and pine cones and fossil bones. The lower right side is the Marshall Creek mastodon, which is at the State Museum. It was found in 1968. Now, it's not in a cave, it was in a bog. But 4 of our bone caves preserve mastodons. One of them managed to capture 20 individuals, and another one captured 1 adult and 6 juveniles. The top left is a complete skeleton of an American cheetah, which was discovered in 2020. Now, this one's in Southern Virginia, but 2 of our Pennsylvania bone caves have scattered bones and teeth from these incredibly fast land predators. So based on the plants and animals that we find accumulated in the cave, we can reconstruct the climate and the ecosystem of the past. Pennsylvania has 9 bone caves, and I included one of Maryland's too because it's kind of unique. This is the map of the locations. The thin green line is the pre-Illinoisan glacial front. So that was 770,000 years ago. That was where the glacier sat in Pennsylvania. And they've advanced and receded many times. We have at least 5 recorded in northwestern PA. And sometimes they can come and go and not leave a record. The blue line is the Wisconsin and glacial front. Now, that was our last ice age, and the maximum was from 17 to 22,000 years ago. So there's plenty more caves in Pennsylvania that hold modern animal bones that I didn't include in here. Kind of picked more of the ones that were historical, the older time capsules. The cave in Cumberland County, Pennsylvania, and Durham Cave are mostly modern animals, but they do have some of the extirpated Pennsylvania animals, like they used to be here and now they've moved north, like wolves, lynx, mountain lion, elk, moose, caribou, and bison. But all of the rest of the caves contain some of these really amazing, the extinct creatures, like saber-toothed tigers, dire wolves, tapirs, these giant ground sloth that were 30 feet tall. There were some early horses, short-faced bear. I mentioned the mammoths. There were also mastodons and giant beavers that were the size of a Volkswagen. So these discoveries were made from 1850 to 1981, which I think is pretty neat, that we're still coming across new discoveries. Here's kind of the timeline sort of laid out. So the cave names are across the bottom, and I put them at their earliest animals because they continued to collect animals all the way up to the present. The 3 different ice ages that I mentioned are shown at the top. So the bone caves have sort of a spotty record from 750,000 to present. The time period is the Middle Pleistocene to recent. And there was neat history in the Middle Pleistocene. The planet switched from a glacial cycle that was like every 41,000 years, advance and retreat in fits and starts, but that was basically the cycle, to one that was a longer period, 100,000 year cycle, but it had shorter interglacial periods. And the interglacial periods are those nice warm times when sort of the tropical animals and the prairie animals and plants can thrive. So we have the Port Kennedy and Hanover bone caves preserving some of the very early history. That Cumberland, Maryland cave recording about 200,000 years ago. Then a gap, but then a big cluster at our last ice age. The Frankstown bone cave, the New Paris, Hartmann's and Hostermann's, to much more recent, like Bootleggers and Durham and New Paris. And just by looking at the assemblage of animals, there's some, like the younger caves have caribou and muskox and snowshoe hare and lynx and wolves and wolverines, well, those critters prefer it a little cooler than Pennsylvania today. So we have records of the warm interglacial periods. Fort Kennedy Bone Cave and Hanover Bone Cave had American cheetahs and jaguars and giant tortoises. Those guys aren't going to be happy in Pennsylvania today. There were also some prairie species like the modern Midwest gophers and badgers and 13-line ground squirrels. And then, of course, some of our caves captured more of the Arctic-like glacial period, where the pollen is telling us that it's an Arctic willow or a spruce or fir type of forest, not the oak hickory we have in Pennsylvania today. There's mammoths and mastodons, saber-toothed tigers, musk ox, and here's a picture of a yellow-cheeked vole. And much of the early work focused on those megafauna, those big, exciting animals. But more recent work, and with new technique and just a different focus, they're looking into the smaller critters, the turtles and snakes, the rodents, even things like snails and millipedes, which all tell a little bit of the history. Our caves also have some evidence of humans past. The Bone Cave in Cumberland, PA, shows evidence of humans breaking the bones to get to the marrow. So it's basically their lunch scraps. Hartman's Cave has a stone tool called a celt. There's also bone awls, fish hooks, and needles. Whether the people were visiting the cave or it just washed in. I think one of the neatest stories is the New Paris No. 2 bone deposit, which included an adult male elk. Now, this is the eastern subspecies that has since gone extinct. But in the skeleton, in the vertebrae, two of the vertebrae were fused together over a broken flint arrowhead. So that's shown in the circle. The little A and B are pointing to two of the tips. So this elk was shot, but escaped, and it healed. And he was doing well until he fell into that bone cave and couldn't get back out. And this was dated to 820 AD, which is about the same time as the Meadowcroft rock shelter was occupied. And of course, we have human graffiti from the 1800s to present. And it all just becomes part of the record. Now, we can also look at the sediment, the sand and the gravel, the boulders and the cobbles that have accumulated in the cave, and they hold clues about the past. We can date these sediment piles, especially with that OSL dating. We can also learn about the climate. If the glaciers are nearby and all the groundwater is frozen, and nothing's going to wash in. But if the glaciers are far enough away that we're more of a permafrost situation, like Alaska and northern Canada have now, in the spring, there's a pretty rapid thaw and melt. And in just a few weeks, a lot of water and sediment will get flushed into the cave. And it doesn't have the opportunity to sort it well. If you look in a stream, you'll see there's some sorting where the coarser material is in one area, the finer is in another. But if it's all just getting kind of flushed in there and dumped in there, it doesn't get sorted. From the age of the sediment, we can also learn about some things on the surface. So the one example is Mammoth Cave has 5 different layers, and the top one is the oldest and younger as you go deeper into the hillside, because the nearby stream was down cutting. And when it would down cut, the water table would change and a cave layer would form lower down. So the upper layer is dated to 3.2 million years ago. And younger on down, but we can look at how far that is from the current riverbed, and that's like 400 feet of down cutting in that time. Another one of the items in our cave that we can get some good historical information from are the formations and the drip water. So the drip water can tell us about recent climate, groundwater travel times, some historical rainfall rates, and chemistry. Australia has been using them to look at their paleo wildfire record. Now, when it comes to the actual stalactites and stalagmites, these formations form when that carbonate-rich groundwater enters the cave and it drips down the formation or plops onto the floor, leaving behind a little bit of material each time. Within that, there's oxygen isotopes and carbon isotopes and the deuterium, and we can look at those isotopes, and that tells us a history. So for example, oxygen has a heavy and a light isotope. It's a O18 and O16. When the glaciers are advancing, they're preferentially locking up the lighter. So the rest of the water available is enriched in the heavier. So we can see that changing ratio and know what's happening with the climate. Now, if the glaciers are real nearby, there's no growth of these formations because the groundwater is frozen. We can use some uranium-thorium dating to get exact ages on these formations. And you can do a sort of a transect, a line down the formation to get, a detailed history. Here's a slide of a thin section of a formation. And if you look at the lower left, the scale is 20 microns. That's 1/4 of the diameter of a human hair. So very tiny, but we see these dark and light bands. And these are annual growth rings. And it's related to the surface, the plants growing, and the soil microbe activity getting sort of translated down into the cave and deposited in these bands. Now, unlike tree ring dating, the trees got to grow every year. These formations can stop growing and start again, but there's some information in there, which is all part of the story. So our Pennsylvania caves, once they form, become these time capsules where fossils and sediment and cave formations can tell us a little bit of the history. And I'm looking forward to scientists discovering new ways to look at the contents of the time capsule, and also discoveries of new locations to study in the future. So we've got time for some questions, but I have one more slide. I just wanted to share my contact information, which I know they'll also share in the chat. If you're interested in just starting to learn about your neighborhood and what's underfoot, we have a website which has our bedrock geology. It has our wells and some of our publications, and it's a good place to start your search.
Thank you so much. We're going to start with a less serious question. So what is the coolest cave or geological location that you've visited?
Oh man, that's a tough question. I'm very fond of Butler Cave in Western Virginia, just because we get to go and visit it. It has these amazing sediment stacks, and we're starting to get more students and people interested in the research. And it's like peeling an onion. There's so many layers, but there's less crying.
So what other scientists besides geologists work in caves?
Oh, well, you would have biologists and microbiologists because our caves are habitats for these unique animals that are adapted to living there or that just, use it for part of their life cycle. Um, the lower 48 states have over 1,000 species that can only live in caves. So the biologists that want to study those species have to go in the caves. There's microbe communities in the caves. So the microbiologists are in there. They're studying especially the extremophiles and related to, what might be in the subsurface on Mars or the moon. Well, what's living in our subsurface? Let's look at home first. You could have climatologists. I'm sure there's all sorts of scientists that like caves.
Well, that leads to a different question. So, can the work be dangerous? We're assuming yes, seeing the pictures of the caves. And do you need to have spotters or work as a team? Is there some sort of system to make sure that you're safe?
Mhm. Um, well, of course, all the cavers have, go in groups, have a plan, match your skills. If it involved diving, I'm not going. If it involved, climbing up ropes, I'm not going. So I'm going to stick to my skill set. Um, and hopefully everyone else does too. In the case of the American cheetah that was discovered in Virginia, they found the scientist, the paleontologist, they wanted to study it, and they trained him because they knew they'd have to break it in pieces to bring it to the surface. And he knew there were certain bones that if you broke them, his research would fall apart. So he learned what he needed to learn to go in there safely. Of course, the work with the Pennsylvania bone caves was done by paleontologists, whether they were from Smithsonian or Carnegie or our own Pennsylvania State Museum. The context of what was in there is important. You can't just grab them all and throw them in a bag and take them to the scientists. They'll be like, oh, it was important to know the layers, or did you look for the mouse toe bones when you were in there? So you definitely want, professionals doing the work, and sometimes they have to be trained to be able to go and do it.
So, are the bone caves open for public visitors or is it private? Do you need permits? And if it is open, can you take something out of them?
Oh, well, please don't. Some of our bone caves were actually encountered in quarrying um, activities. So they were extracting the limestone and they cut into the bone cave. And so they got the scientist in there, take the bones, and then they kept on quarrying. So those have been destroyed. Some of them are available to visit. You'd want to check with the local grottos. They would be the ones that would have um, the permissions and the contacts. And of course, we'd say never take anything out because it's all part of the story. And maybe the first scientist in there didn't get everything. Some of these were done in 1850. So maybe something new's been exposed due to erosion, or there was a nook they didn't look in because their lanterns weren't bright enough. Whereas now we can turn on an LED light and say, well, there's something way up there we didn't think about.
At the beginning of your presentation, you showed a cave that was in Greene County. What was that cave?
So Western PA, it's there's Sarah Furnace and Harlansburg. And I'm trying to think which one's in Greene County. I'll have to get back to you on that one.
Okay.
There's over
All right.
400 caves, over 100 feet long in PA, and I definitely don't have
You don't know all of them.
a tenth of them memorized.
So even though the general public can't visit some of the red dot caves, the Geological Survey can, we're assuming. And can you tell us a little bit about what the general public doesn't get to see that's in those red dot caves?
Um, so as far as I know, the Pennsylvania Geological Survey doesn't particularly get special access.
Okay.
It's really more the cavers who have agreements with landowners, and they're the ones that help to assist in the protection and also control who comes in and who goes out. And if somebody thinks they have something interesting, they can contact us and we can put them in touch with the right group. or they can look, I think in the chat, we're going to have that information available.
Yes, I think it's in there, and we will have your information for contact repeated in there as well. So there's a lot of questions we have. So we're going to get to some serious ones. Who provides funding for cave exploration and data collection?
Nobody. Seriously. So some of them have been funded like by National Geographic through their Young Explorers Club, or maybe like a local historical society might have some funds, but there isn't a group that pays for it, and it's kind of really backburnered.
So someone in the audience noticed carbon capture legislature in the headlines recently. Can you speak about what that looks like in Pennsylvania and how that might impact geology?
A little bit. So carbon capture is, we know carbon dioxide in the atmosphere is contributing to this changing climate, and we're going to have to live with this new climate. So the one idea is to remove it from the atmosphere and put it underground. So that's sort of the short of it. There are all sorts of challenges. And it's really our Pittsburgh office who's spearheading that research in Pennsylvania. So you'd want to check with them on that. It's new technology, so like with anything, there's a learning curve. I can't say if it's safe or troublesome. They definitely want to trap it down deep. You don't want it coming back up, or it'll get out in the atmosphere, which is what we're fighting against.
So what kind of laboratory equipment is used to analyze cosmogenic dated materials?
I am not entirely sure.
That's a great answer. So when all else fails, it's time for a Google. So, yes. Well, perhaps this one would be something more along your skill. What levels of radon have been measured in caves?
That's a good question. Because of course, we have radon being generated by our basement rocks. We have radon coming from our glacial till. And limestone itself, dolostone and marble, they are very low generators of radon. But the fractures and the cavities are places that radon from much deeper can come up and pool. I know typically, when you consider a lifetime exposure, how often is a caver visiting a cave? It applies more for the people working in caves, because they are spending 40 hours a week or more being the tour guide and being exposed to it. So there are places that monitor for radon. Kind of the bigger risk is like a low oxygen level. And people can carry like a carbon dioxide alarm or meter with them, just to make sure that there's enough fresh air in there.
Well, that leads right into the next question. Do you use an oxygen meter or a hydrogen sulfide meter when you go into deep caves?
Well, I don't go into deep caves. So definitely the people doing that exploration and pushing deeper and pushing farther, going into new areas, would want to make sure and have that level of protection.
You mentioned the dating technique. So for the optically stimulated dating technique, since being exposed to light for 2 minutes restarts the clock, is it possible or common for the dating to be unreliable, since there's no way of knowing about historical UV exposure?
So our assumption is that sand grain was out in the sun, clock set at 0, it got washed in the cave, where now, once it is in the darkness, the clock can start ticking. We collect our samples in darkness. So you pick the spot, everybody turns off their headlight, they hammer in a tube, pull it out and cap it, and then you turn your lights back on, and they note which end would have maybe been exposed to headlights before and which end was inside that sediment pile. When the archaeologists are going to collect it, I know the one they dated was a stone pillar in New England. And the question was it German farmers or was it Native Americans who built this? So they put black tarps and tunneled under it in the dark and collected their sample in the dark, brought it back out under the black tarps, and then took it to the lab, made sure it stayed dark. The lab can tell by the error bars. So they can tell if it's been contaminated a little bit or really mixed. Like if you had two different sands that were mixing together into that deposit, they would get error bars and they could tell you, like, don't trust this one, or let's try it again with a different sample.
This is fascinating. So all the bones and fossils that you talked about in the bone caves that were discovered from the 1800s on, where are those today and can we view them?
So good question. The ones that have not been lost are at the Smithsonian, Carnegie Museum, the Philadelphia Academy of Science, and our own State Museum. Now, the State Museum has a bunch of their collection online. So digitally, you can look at all the pictures of the different things that were retrieved. So Hosterman's Pit, those samples are in the digital catalog and in the State Museum. Now, typically they're not on display. I think if the different museums were doing a special exhibit, they might bring them out, but they're in the collections. And you can request a behind the scenes tour. You know, you can visit Smithsonian and say, we see all this neat stuff out front, but we know there's a whole lot more in the back. And each of the museums will provide a behind the scenes tour if they have the staff available.
And that is true here for the State Museum as well.
Mm-hmm.
So we're going to get to a personal question for you. What is the scariest experience you have had in a cave?
Try to avoid scary experiences.
But
I don't like tight spaces. So what I've sort of pushed my comfort zone. If it's a hands and knees crawl, I'm okay. But if it's like an army crawl or smaller, I've gone to places and looked and said no. And any other good caver is going to say, yeah, we're not going. They don't want me to freak out just as much as I don't want to freak out. I've also had kind of the odd experience of being in a cave and being uncomfortable with the heights. You know, there's some passages that are 80 feet tall and you're up on the top and you're looking down, and I'm like, because I am a little afraid of heights too. There's just a happy middle ground I try to stay in.
That's always a good place. One last question. Have there been any work with drones inside caves?
So really good question. Earlier generation drones rely on GPS technology to not wreck into things. And there's no satellite signal in the cave. And so if it's approaching a wall and it says, okay, there's an obstacle, I need to back up, it doesn't know which way back is. I know some people have flown recreational drones in caves and, you know, sometimes they wreck, but they're recreational, so it's okay. But the technology is getting better and better, where you could have a base station, or I've seen even drones they send into sewer lines, which are built in like a ball of protective plastic. So it doesn't care if it wrecks into the wall because the drone itself isn't wrecking into the wall. So I'm sure we're heading towards that, where drones can do some of our cave mapping or cave exploration for us or with us.
Terrific. Thank you, everyone, for your questions. Rosanna, what would you like the audience to remember from today's presentation?
Well, I just want you to remember that Pennsylvania has some really interesting geology, and you can start digging into it and head down a rabbit hole and just discover what our past is.
Terrific. Thank you so much for joining us today.
Well, thank you.
We ask the audience to join us again for more Learn at Lunchtime programs from the State Museum of Pennsylvania. Please go to the State Museum's website at statemuseumpa.org For more program information and to sign up,